All right, who's ready to do some PSSA fun? I know I am. Stole this packet from the internet, and there's, I don't know, it looks like a typical PSSA. It's designed exactly the way the PSSAs are designed. They look like PSSA style problems. So I'm going to do this the way I would do it if I were a nerdy math student, which means I'm just going to do it the way I would do it. End sentence. Problem 1. Question 1 in this sampler is to be solved without the use of a calculator. So let's take a look at problem 1 here and do this without the use of a calculator. I have 7 to the negative 8 times 7 to the negative 4. What I would do is whenever you see, let me rewrite it out here so it's a little bit bigger and I have all the space I need. If I have negative exponents, I move it to the other side of a fraction bar. In this case, I don't have a fraction bar, so I'm going to make one right here. Now, I have 7 is attached to a negative exponent of negative 8. So this guy is going to move to the bottom of a fraction bar and become 7 to the positive 8. This guy's 7 to the negative 4. That also is going to move to the bottom of the fraction bar and become 7 to the positive 4, and it's being multiplied like it was in the numerator. If I'm left with nothing up top, I have a 1 there. Okay? I have 8 7s right here attached together. 7 times 7 times 7, 8 times. I have 4 7s attached here. 7 times 7 times 7, 4 times. If I were to write all that out, that would be 8 7s, 4 7s, 12 7s. Well, the trick here is I should be able to look at this and say, well, if they're next to each other, if you're multiplying, add the exponents. 8 plus 4 is 12, so I have 1 over 7 to the 12th power, which is A right there. Okay? Problem 1, donezo. Problem 2, which equation shows how to find the product of a million times a million using scientific notation? All right, so I'm going to make believe I didn't see the options here. It's clear what they want me to do is write both of these out in the scientific notation and then use the little trick that I just used on the previous page. So every 1 million, here's a million, 1 with 6 zeros after it, all right, yep. Put a dot there, that's a change of 1, 2, 3, 4, 5, 6. So every a million is 1 times 10 to the 6th. So a million times a million is 1 times 10 to the 6th times 1 times 10 to the 6th. These parentheses are useless. So if I were to rewrite this out, and again, what I'm doing is I'm showing every single step here. 1 times 10 to the 6th can be written out as 1 times 10 to the 6th times 1 times 10 to the 6th. Again, those parentheses are useless. I'm going to move these 1s right next to each other, 1 times 1, and I'm going to move those 10s next to each other, times 10 to the 6th times 10 to the 6th. Let me get my calculator ready. 1 times 1 is 1. 10 to the 6th times 10 to the 6th means we add exponents, just like we did in the previous problem. Add the exponents, and that gives us 10 to the 12th. So I have 1 times 10 to the 12th. All right, so let's see what we have here. I'm going to eliminate C right off the bat because that says 10 to the 7th and 10 to the 7th, and so does that, and so does that. So those two are wrong. Okay. This does say 1 times 10 to the 6th. So does that. These are all 1 times 10 to the 6th. However, it's hard to see, but this guy right here is saying 10 times, or 6 times 6, which is 10 to the 36. I added exponents. I didn't multiply exponents. So since I added exponents, not multiplied exponents, my answer is going to be A, because that's what I'm supposed to do. Mr. Carter is mapping the boundaries of a park on a coordinate grid. The park's headquarters are located at the origin. That means 0, 0. The equations shown below represents two boundaries of the new park. Park's entrance is located at the intersection of these two boundaries. Which coordinate grid correctly shows the two boundaries of the park's entrance? All of this means nothing. All we care about is graphing these two equations. So here's the top equation. Y equals 2x minus 5. I can graph that right now, nothing to it. The bottom equation, however, is not graphable, so not yet at least. So I have 2x plus 4y equals 12. In order for me to get y all by itself, I have to subtract 2x, subtract 2x. So I have 4y equals negative.
Fatima Amador, Meyer Baker, and Matthias Stewart to the main office. Fatima Amador, Meyer Baker, and Matthias Stewart to the main office.
Negative 2x plus 12. Divide everything by 4. Divide by 4. Divide by 4. When I do that, I get y equals negative 1 over 2 because negative 2/4 is 1/2. X, 12 divided by 4 is 3. So I need to pick a graph that has y equals 2x minus 5 on it and y equals negative 1/2 x plus 3 on it. So let me start out with this guy, y equals 2x minus 5. I need to pick a graph that definitely goes through negative 5 and has a slope of 2. So all of these go through, all of them go through negative 5. There, 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 and there. I'm going to get rid of the ones that don't have a slope of 2. Okay? You have a slope of 2, so this one checks out so far. You have a negative slope, so you're no good. You have a slope of 2, so that checks out so far. And you have a slope of positive 1 over 2, which is a half, so you're out. So I'm left with A and C right now. My other equation is y equals negative 1/2 x plus 3. So I need to pick a graph that goes through 3 and has a negative 1/2 for a slope. Well, right away looking at C, C doesn't go through 3, so C's out of the question. A's got to be it because it goes through 3 and has a slope of negative 1 over 2, negative 1 over 2. This seems to be the only guy that does it. A is my answer. All right, problem 4. A cleaning company charges X dollars per hour to clean floors and Y dollars per hour to clean the rest of the house. X dollars floor, Y dollars rest of the house. When the company spends 2 hours to clean floors and 3 hours to clean the rest of the house, the total charge is $84. And here's another sentence just like it, and they want an ordered pair as an answer. This is looking like a system of equations problem. So let's set it up. 2 hours to clean floors. 2 hours to clean floors is 2x. 3 hours to clean the rest of the house is going to be 3y. And that's going to total $84. When the company spends 1 hour to clean the floors, 1x, or just x, and 4 hours to clean the rest of the house, it's $87. What I'm going to do is I'm going to do elimination. I like elimination because everything's lined up, and all I'd have to do is just multiply this bottom equation by negative 2. So when I do that, I'm going to keep the top equation as 2x, you know what, I don't like green, it doesn't show up as well, 2x plus 3y equals 84. The bottom turns into negative 2x minus 8y equals negative 174. If I add these up, that crosses out. Negative 8y and 3y is going to be negative 5y. 84 plus negative 174 is negative 90. Divide negative 5 from both sides to get y all by itself. Y equals 18. Now that's nice because y is not 20 and y is not 15 and y is not 12, y is 18, I'm done. If I wanted to find x, I could take this bottom equation, rewrite it out. I'm not going to write out the 1 in front of x because it doesn't need to be there. I can replace y with 18, so x plus 4 times 18 equals 87. Okay, 4 times 18 is 72, so that's what I have there. Subtract 72 from both sides, subtract 72 from both sides. X equals 15, which gives me the point 15, 18, B, Dunzo. Mariana has been adding $30 to her savings account every month. Which model could represent the money in Mariana's savings account? Y after X months. All right, so she's been adding $30 per month. So 30 per month means I have to be going up by 30X or something along those lines, which takes care of A. You're gone. B's no good because it has a negative there, so you're taking away 30. C looks initially like it can't be right, but I have a feeling it is because although these go up by 60 every time, these go up by 60, these don't go up by 1, these go up by 2. So remember, rise over run is y over x, 60 over 2 is $30. So C has potential, but I'm a little nervous about it. Let me take a look at D. If I'm going up $30 per month, this is basically saying I'm starting out with $30 and after a month I'm going up like $3. That's not going to help me anyway. So D's no good, C's got to be it. Problem done. 6, the graph below represents a function. Sure does. Which single transformation could be applied to the graph so that it no longer represents a function? So this is what I'm thinking. If it's a function, it's got to pass what's called the vertical line test. If I were to draw a vertical line, it's got to hit just once. So I have to do something so that if I were to change this shape and draw a vertical line, like for example, this is not a function because if I draw a vertical line through a circle, it hits twice. So I need to change this U-looking thing into like a sideways U or something like that so it stops being a function. So if I reflect it across the x-axis, okay, this is the x-axis. If I reflect it across the x-axis, it turns upside down and looks like that. That's still a function because you can draw vertical lines through it and it would still only hit once. A reflection across the y-axis would just spin it and you would end up getting the same exact picture. So A and B are out. A rotation 90 degrees clockwise would take this shape and tilt it sideways. So if I were to imagine this shape sideways, I now have that sideways looking U and it no longer becomes a function. So C makes it not a function. D would just be moving it to the left, which means I'd get the same exact shape, so D's not it either. C has to be my answer. Tricky, 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 tricky. Problem 7, 2 linear functions are shown below, 30x plus 19, and then I have a chart. If I wanted to, I could use this chart and use linreg, which I'm going to do because I haven't really touched the calculator yet. I'm going to do the yellow calculator for linreg. Go to Stat, Edit, type in your numbers, -12, enter, -8, -3, 1, -311, ugh. -211, -86, 14. Okay? Type that in exactly as it appears. Second mode, Stat, Calc, linreg, enter, and this guy ends up being y equals 25x minus 11. So over here my slope is 30. Over here my slope is 25. Over here my y-intercept is 19. Over here my y-intercept is -11. So let's go over these. Function 2 can be described by the equation 35 minus 109. Nope. Function 2 can be described by the equation y equals 100x minus 11. Nope. The y-intercept of function 1 is less than the y-intercept of function 2. Nope. The rate of change, or slope, of function 1 is greater than the rate of change of function 2. 30 greater than 25. Yerp. D. What you talk about Lewis? Well, let me tell you about Lewis. He's talking about building a new deck and needs to have a slab of concrete poured. He knows the contractor charges initial cost of $75 plus an additional $2.50 per square foot of concrete. Which equation can be used to determine the cost Y in dollars to pour concrete slab? Well, it's right there. 75 plus 2.5x. 75 plus 2.5x. Finally, a friendly problem. Done. The graph below shows the relationship between the number of years after a car is purchased and the car's value. So it looks like, and this makes sense, if you buy a car and you buy it for $30,000 brand new, as the year goes on, or the years go on, it lowers in value. So here we are starting at 300,000, okay? It is saying which statement is true. The car's, all right, so again, let's read through it because I have a feeling right away I could just eliminate two possible answers. When I buy the car brand new, it's $30,000. A and B says the car's initial value is $2,000. Nope. The car's initial value is $18,000. Nope. So that eliminates A and B. It looks like as time goes on, it goes down. So I'm going to pick another point that I can make sense of. That one. My slope is going to go down. Down 1, in this case, means I'm actually going down from 30,000 to 24,000, which is 6,000. And you can see from here, every block is 6,000. So I'm going down 6,000. When I go over 3, I actually am going over 3. So negative 6,000 over 3 is going to be negative 2,000. So what this negative 2,000 means is if I buy a $30,000 car, it goes down $2,000 in value per year. So the car's initial value is $30,000 and the value decreases $2,000 per year. The answer is C. Looking at some of these options, I don't know where they get the 1,200 or the 1,800 from, but, you know, that's the options that they have. The only answer that makes sense is C. All right, problem 10. Which coordinate plane shows that the shaded polygon is the image, which means the answer, of the unshaded polygon after a 90-degree counterclockwise rotation about the origin? So the way this is worded is awful. This is basically saying the shaded is the answer. The original is the non-shaded, and they want to go 90 degrees counterclockwise, which means if I have a shape that starts out over here, 90 degrees counterclockwise ends up over here, and they want to shade it. So this eliminates C, because C is not even moved. It's not even rotated. Yes, it goes from one spot to another, but there's no rotation. It just kind of moves over. D doesn't make sense because it's just like a 180 or a reflection looking thing. B. Now, this is where we have to be careful. My answer in both of these cases looks like this, I don't know, like a Superman logo, to be honest. But the reason why A can't work is if I were to test out A. All right, so this is the original, right? This is the original. If I were to go from here to here, A actually is the answer. Did I say it can't be A? A is A. Yeah, it's A because this long side here flips over to the long side over there. The top part flips over here, and the side part, it just flips everywhere. This guy is a reflection. If you look closely, it's a reflection. So B, although it looks like it goes in the right order, B is not my answer because it just simply reflects. A rotates. Remember, when we do rotations, okay, my shape is going to move and things go sideways. B doesn't do that. It reflects. This reflects, that translate, that is a 180. The only one that makes sense is A. All right, problem 11. This is one of those weird problems that you just really have to read through before you actually do it, because if we're going to be honest, I did this problem already and I have to redo it again because I screwed up. In the figure shown below, triangle PQR is transformed to create triangle PQR with the primes on the PQR. So this is what it looks like they're doing. It looks like they're reflecting and then moving. Okay, that's what my guess is. They're taking this guy right here, okay? They're reflecting it over the x-axis and they're moving it maybe a little bit. So this is what I like to do with shapes. I like to pick one point and do what I think they're doing. So what I think they're doing, Now, and I take it back now, because like this is what I did before. I remember doing this, and I did this before. Looking at the answers, it looks like they want to move it before they do anything else. I'll tell you one thing. They're not rotating it. If they're rotating it, then it would have to be like flipped around in some way. Like, you know, the Q would have to be at the bottom or whatever. That's not what's going on here. So it's not a rotation, it's not a rotation. They're moving it and they're reflecting it. So if I want to get to this R, it looks like I have to move it left twice, right? And then go down 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So they're moving it left twice, then flipping it over the X, okay? Moving it left twice, flipping it over the X. So what I have to do with S is do the same thing. Move it left twice and then flip it over the X to land me here. So S is being moved to 4, 3, which is right, and then reflected to 4, -3. That's a brutal problem. That's a tough problem. So, yeah, good luck with that. All I have to say is you just have to really look at what this guy is doing, look at your answers in options 2, and then base what you decide to do off of the options that you're given. That's ultimately what I had to do here. Hooray! All right, problem 12. A balloon in the shape of a crayon is shown below here. It's a balloon. A crayon balloon is made up of a cone and a cylinder. That triangle is a cone, apparently. And that rectangle is a cylinder. So I need to find the volume in cubic inches. Well, if that triangle is supposed to represent a cone, let me make it all 3D and stuff. It's 3 inches tall. Now the radius is going to be 1, because if this is supposed to represent the cylinder, right, which is 21 inches long, if I were to tilt this sideways, the whole diameter, the whole length here would be 2, which means the radius is 1 and the radius is 1. So I have a cylinder, which is pi 1/3 pi r squared h. It's a cone. I'm going to plug in what I know. I know that 1/3 is 1/3, big whoop. Pi is pi, yippee. R is 1 squared. H is 3. Let's type it all out. Oh, technology, what a privilege. 1/3 pi 1 squared, which is 1, 3. All right, look at that, it's pi. 3.14. Okay, so that's my cone. My cylinder is V equals pi r squared h. My r is 1. My h is 21. So pi times 21 is 65.97, so we'll say 66. If I add these two together, 66 plus 3.14 is going to end up being 69.14, which is close to 69.12. I don't know, maybe they use 3.14 instead of pi. I don't know, who cares? So what? Big whoop. Problem 13. Part of a sculpture is a stone sphere with a volume of 36 pi cubic feet. What is the radius in feet of the stone sphere? As you all know very well off the top of your head, the volume of a sphere is 4/3 pi r cubed. What do I know? What do I know? Well, I know the volume is 36 pi. So 36 pi equals 4/3 pi r cubed. In my opinion, the easiest thing to do is there's a little trick if you see pi on both sides and all you're doing is multiplying throughout the entire problem, you can cross pi out. So I could do that, but I won't. I'm going to actually just type it out. 36 pi is 113.1. 113.1. 4/3 pi is 4.2, we'll say. 4.2, and then our cube gets detached. Okay? Divide both sides by 4.2. Divide both sides by 4.2. Cross u out. 113.1 divided by 4.2 ends up being 26.92, which I'm going to round up to 27, and you'll see why I do that. That equals r cubed. Now, in order to get rid of an r cubed, I have to cube root both sides. If I was getting rid of a square root, I'd square root both sides. So to get rid of a cube root, I'd cube root both sides, and the cube root of 27. And just a quick math reminder, if you wanted to do cube root in your calculator, it would be math 4. Math 4 gives you that cube root. I already know what it is. It's going to be 3, but why not type it in and just validate? Oh, look, it's 3. So r equals 3 feet. 3 feet. Done. Christy created the scatter plot shown below. So it looks like we have a positive correlation with an outlier floating down there. Christy finds that the line of best fit for the data has the equation blah, 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 which statement best explains how removing the point 15.7, the outlier, would affect the slope of the line of best fit. So if we're doing the line of best fit, right, if we're actually doing like lin-reg and we're plugging all these points in, if I get rid of a really small number, just think of it this way. If you're in a room with a whole bunch of teenagers, right? If you're a teenager and you're hanging out with all your teenage friends and all of a sudden a baby walks in that doesn't belong, that baby is going to bring down the age of the rest of the room. Okay, if I remove that baby, then that age goes back up to normal. So if I were to remove this x, okay, what this x is doing is maybe the line of best fit looks like that because of that dot. But once I get rid of that dot, the line of best fit increases back to normal. So the slope increases back to normal, which means you're out and you're out. The slope of the line of best fit would increase because the point lies below the original line of best fit. I mean, this doesn't even make sense because the point is above. So, yeah, weird one. Another weird one. C is the answer. Scatterplot. Below shows the temperatures Y in degrees Fahrenheit, whoop-de-doo, that were recorded over different altitudes, X and thousands of feet, thousands of feet, thousands of feet. What equation could represent the line of best fit for the temperatures in degrees Fahrenheit based off the altitudes? All right, so there's one of a few options. You can attempt to do lin-reg here. It's not a bad idea, but let me make this as easy as humanly possible. I'm going to draw a line of best fit. My line of best fit, when drawn out, looks like it goes through the 60 range for a y-intercept. If I'm thinking y equals mx plus b, I have a negative slope. It looks like my slope, if I were to pick like two obvious dots, my slope would be somewhere in the 20/6 range, which is, well, negative 20/6 range. X, I'll simplify that in a little bit, just relax. My y-intercept's like, I don't know, 59, 60-ish, so we'll make it 60. Who cares? If I simplify this, negative 20/6, divide everything by 2, divide everything by 2 is going to be like negative 10/3 x plus 60. The dead giveaway is this plus 60. It's definitely not plus 47. Plus 47 would mean that my y-intercept is here, and it's definitely not that, so we can rule out A. B is probably it, but let me rule out the others. Plus 69 would be way up here. It's definitely not that. Plus 80 would be way up here, so it's definitely not D. B is it. Now, if you're not convinced of the slope here is negative 7 over 2, which is negative 3.5. The one that I predicted is negative 10 over 3, which is negative 3 1/3. Close enough. 59, close to 60. B is the answer. Yay. Blake interviewed 24 students to see whether they collected sports cards and whether they participated in sports. Whoop-de-doo. The table shows his data, so here you have it. How many... Okay, so we interviewed 24 students. So what we're missing here are the totals, so let me add that. I would draw the totals out because I like totals. 6 plus 3 is 9. I don't know what that's going to be. That's going to be 10. I don't know what that's going to be. So reality is I need to pick a number here so that when I add everything up, I get 24. Right now I have 7. All right, so 7 plus X is 24. Now here's just, you could, probably the easiest way to do is just plug in 4 and see if it gives me what I get. Plug in 4, see if 11 plus 9 is not 24, that's it. I'm going to set it up like this. 9 plus 7 plus X equals 24. 9 plus 7 is 16 plus X equals 24. Oh, wait a minute. Yeah, okay. Subtract 16, subtract 16, X equals 8, which means you're 8. So how many people participated in sports? 6 plus 8 is 14. That's a weird problem, but whatever. I don't care anymore. All right, we've made it to our open-ended problem, problem 17. Good old Bill here used a rain gauge to measure how much rain fell in centimeters during a rainfall. The rain fell at the same rate throughout the first 180 minutes of the rainfall. Complete the table below with the number of minutes it took for 9 centimeters of rain to fall and the number of centimeters that it fell for 150. So it looks like the pattern up here is 30 to 45 to 60 to 90. And here's the tricky part too. Here's the tricky part. It looks to me that for every 15 minutes, it rained 1 centimeter. So this is what I have to be very, very, very careful of. This is a change of 1 centimeter. This is a change of 2. That's why instead of 15 minutes, it's 30 minutes. This is a change of 3. So instead of 30, it's going to be 45. Tricky, 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 tricky. So that becomes 135, and then it changed, I don't know, but if it goes up 15 here, it looks like it only changes by 1, which means that guy's going to be 10. Boy, is that a crazy problem. Sure is. So now what I have to do is I have to write an equation to describe the relationship between time, t, in minutes, and the amount of rain, r, in centimeters. I'm not going to use ln-reg because ln-reg would be very easy, although I would highly suggest you do the same thing. It's simple. Every 15 minutes, it rains 1 centimeter. So the amount of rain that we get is going to be 15 times my time. Okay? If you did ln-reg, you would get y equals 15x. And you would know that the rain is supposed to be my y and the t is supposed to be my x. Okay? A and B, done. Off to C and the others. The total amount of rain that fell from 180 minutes through 100... Describe the change in the slope between the first 180 minutes and the following 100 minutes and explain what it means in terms of the total amount of rainfall. All right, so it looks like my slope is going to be, let me see, that point, I want better points than that. That's a good point. We'll stick with that. I don't like it, but we'll stick with that. Looks like that's about 12. Okay, so that we'll say that that's 12. and it goes up maybe over 20 minutes. It goes up maybe 2 centimeters. Okay, so over 20 minutes, it's 2 centimeters. So 20 minutes, although it should be minutes down here. 20 minutes, 2 centimeters. The slope is 1/10, which means it rains now instead of 15, or instead of 1 centimeter per 15 minutes, it now rains 1 centimeter per 10 minutes. So what does it mean in terms of the total amount of rainfall? Well, it's raining harder. It's raining harder. Hallelujah, it's raining more. Maybe we should say that because it starts with M like men. It's raining more. You'll get more rain because instead of raining a centimeter every 15 minutes, it's raining a centimeter every 10 minutes. And after 280 minutes, the slope of the graph is 0. Explain what the slope of the graph of 0 means in this situation. It is not raining. If the slope is 0, that means you get 0 centimeters of rain in minutes. That's crazy. No rain. Speaking of no rain, no more packet. Hey, that was fun. I think this is about a 45-minute. Enjoy. Bye.